Hi guys, in this tutorial we have an interesting question to look at. So we are given this diagram here. So this is a diagram we're looking at, and the question is, in the first part, they're saying resolve the force F1 into components acting along U and V axis and determine the magnitude of the components. In the second part, they're asking us to do the same thing but to the force F2. And in the third part, they're asking us to determine the magnitude of the resultant force, Fr, which is given by just F1 plus F2, and its direction, measured clockwise from the positive U axis. Now, how do we do that? Well, let's look at this diagram and see what they're asking us to look at. So the first one, we are being asked to find the magnitude of the force F1, only its component, in the axis, in the V axis, and also in the U axis. So let's see, how do we do that? Well, let's focus on that one. Let's resketch the problem so that we can just look at F1. So F1 is this one here, and then F2 is here. So if we just try to focus on F1 and resolving F1, let's see how we are supposed to look at that. Well, to resolve this, we want to find its pieces along the V axis and the U axis. How do we achieve that? Well, let's take this axis. This is the U axis. So if we were to shift this axis, we see that I don't really want to shift the whole thing. So let me take it back. Instead, let me just copy it. So what I've done here is I've resketched the U axis so that it's just at the far end of our force vector F1. I did this for one simple reason. If we're going to resolve F1 into components, what you should see is that the components have to be parallel to the axis in question. For example, the piece of F1, which is going to be acting along the V axis, has to be a component that is going to be moving in that direction, or a force in this direction. So this is going to be the component of F1 in the V axis. Next up, the component of F1 in the U axis will have to be a component that is parallel to the U axis. So this will be a force that will be acting in this direction. So this is a piece of F1 in the V axis. So this is what we're looking at. So if we have this diagram here, what we should notice then is that, well, a few angles then become almost obvious from here. Which angles? Well, if you look at the same diagram, but just without most of these lines, let me remove everything else and just show you what remains here. If you look at it the way it is right now, first and foremost, you see that if this is 75 degrees, this is a straight line. It implies that less 75 from 180, you get what the angle here is. And these being parallel lines, if this is 105, then the angle here will also be 105. Let's bring everything else back. Okay, so this is what we had. Okay, so we've seen to say that this angle here is 105, and this angle inside here will also be 105. If this is 30, this is 105, well, I'm sure you can guess what this angle here is. With that in mind, it becomes easy for us to predict what F1 in V is, and also, so I wrote in V both sides, this is in U, F1 in U. So it becomes easy for us to predict what these are going to be. How do we do that? Let me resketch it, but now a bit more rough. So we have this. I'm just going to magnify everything so that it's easy for us to see them. This is F1 in the V axis. Then this side, we have F1 itself, and here we have F1 in the U axis. The angle here, we saw to say this is 105 degrees. This is 30. This was given in the question as 30 degrees. And I'm sure you were able to guess that the angle here is going to be 45 degrees. Okay, just make sure. Yeah, that's everything. The force F1 in the question, F1 is given as 4 kilonewtons. Yes, that's 4 kilonewtons. So this is 4 kilonewtons. With this in mind, then it becomes easy what we have to do. Let's say you wanted to find, well, we can start with F1 in U. To find F1 in U, if we used sine rule, it's opposite to this angle. So we're going to have F1 in U, better color. So you have F1 in U over sine the angle opposite to F1U, which is 30 degrees, equal to, we can pick any pair here. We don't know what this side is, so we're going to use this pair. So we're going to have 4 kilonewtons divided by sine 105. From here, we can easily determine what F1 in U is. Sine 105 multiplying 4 kilonewtons. And finally, F1 in U comes out as 2.07 kilonewtons. So this becomes the component of F1 in the U axis. Well, to determine the component of F1 in the V axis, it's the same thing. We're going to use sine rule again, but this time we have F1 in V over sine 45. So that is F1 in V over sine 45, the angle opposite to that side, equal to, so for simplicity we're going to use 4 again, divided by sine, the angle opposite to the 4, which is 105 again. Finally, F1 in V will be equal to sine 45 divided by sine 105 multiplying 4 kilonewtons. So from here, we do the math, and F1 in V comes out as 2.93 kilonewtons. So this is what comes out as the component of F1 along the V axis. I hope you saw the trick that I used here by just identifying that the component of F1 in the U axis will have to be parallel to the U axis here. So this is why I redrew that axis that side. A common mistake that a student might want to make somewhere here is to think that when the component comes here, it will make a right angled triangle here. It won't make a right angle because the component, since it has to be along the U axis, it has to be parallel to the U axis that side. And as you can see clearly from here, the U axis is not perpendicular to the V axis. So because the two are not perpendicular, don't expect them to be perpendicular here. So you don't expect the component along the U axis to be perpendicular to the V axis when you resketch it that side. So because of that, this is why you avoid using or finding the X component to say I'm going to use the trig ratios by their basic way, as you did in first year or in pre-physics, to say the X component. In this case, if had this been a right angle, you would have found this component here by just saying it is opposite to the 30-degree angle. So you'd have used sine. You'd have said it is F1 sine 30. This method doesn't work here. And the Y component, you would have used F1. And since it is side by side, you'd have had cos 30. So again, we're saying this doesn't work here because you're not dealing with the right angle triangle. So it is important for you to notice that. So with that caution in mind, try to see if you can now work out part 2. Because in part 2, they're saying resolve the force F2 into components acting along U and V axis and determine the magnitudes. It's basically the same thing as part 1, but now you're supposed to do the same thing to F2, the force F2. Notice that when dealing with F1, we left out F2 and just focused on F1. So try to do the same thing. Focus on F1, move around one axis so that you can create a triangle. And then after that, see how you can use sine rule to come up with the components of F2 along the U and the V axis. Leave your answers in the comment section. Let's see what you find there. Yeah, so in case you need a hint, I can I'm just going to show you a quick diagram, the diagram that you expect to find in order for you to actually determine the components, just as we did in the first part. So if you can pause the video right now and just try to complete it, but if not, if you struggle, just look at the diagram below so that maybe you can use that to find the answer. Okay, so this is what you expect, something like this. So move around the v-axis, shift it downwards so that it comes down to this point, and then along the u-axis you're going to get the component of f2 along the u, and parallel to the v-axis you're going to get the component of f2 along the v-axis, and then this side you have f2 itself. So from here this angle comes out as 75 degrees because this angle is expected to be the same angle as this one here, and this in the question was given as 75, so this and this are supposed to be the same. And then this is 75, you expect it to be 75 because if this is 30, this is 75, this has to be 75 degrees here. So you should be able to use sine rule and the diagram here to determine the components f2 in u and f2 in v. Leave your answers in the comment section again, then let's see what you find. Right, so we can move on to the last part of the question. Now for the last part, we now want to determine the magnitude of the resultant and its direction measured clockwise from the positive u-axis. Now how are we going to do that? Let's start by resketching our problem so that we can easily manipulate. For starters, I've left out the u-axis. We'll bring it back a little bit later. I've only drawn the v-axis and the two force vectors. Now the next thing that we're going to do here is we're going to now shift the force F1 so that it comes down here where F2 ended. What I want to do is to create a parallelogram. So to do that, I'm just going to copy this vector, clone it so that I bring it back without changing its direction down here. Okay, now that is done, what I want us to determine is the angle that is made down here. Now, how do we find this angle? Well, I'm now going to draw a line here. Now, let's see, what line do I want to determine? I'm now going to bring a replica of the u-axis just here, and I'm going to make another line similar to the u-axis or parallel to the u-axis down at the bottom here. What do I mean? So let me bring down the u-axis. Okay, so we've drawn the line to simulate our u-axis. Now we want to just copy it so that we show another parallel line somewhere here that denotes just that u-axis. So how do we do that? So we're going to do something quick here. We're going to copy this and I'll paste it down here. So let's bring it just right somewhere here. So with this done, so this is just a line parallel to our u-axis. Now, why did I need this? What I want to determine is the angle down here. And why I want to see that, you'll see in a minute. So let's see. Perhaps I should let you in the end here. So I'm looking for this angle for one simple reason. This angle is quite going to be helpful because this is F1 here and this is F2 here. If I can find the angle that is here, then I can easily determine the resultant force that will be given by F1 plus F2, since these will be the two that are here. So to find the F1, I have to move from F1 plus F2. So I have to move, it doesn't matter the order here, since this is addition, it can be swapped. So this is F2 plus F1. So this is what I want to do. So to find this angle, this is why I'm going through all this trouble. Now, how will I do that? Well, for starters, here's what you see here. If I was to extrapolate, so for my extrapolation, let me go blue. So if I was to extrapolate this, the line of action for F2, it would come a little bit like this. And this side, this is given as 30, according to the question, this is 30 degrees. So we expect this angle here to also be 30 degrees. Now, what does that imply? Well, if this is 30 degrees, then the angle that will be here is also going to be 30 degrees. So we expect this angle to be 30 degrees. So to show you that that is 30, let me just erase a few things and hopefully you're going to see why that has to be 30. So let me remove this. Let me remove this as well. And let me just leave the two parallel lines. So I hope when you see it like this, let me remove this one as well. I hope when you see it like this, you see that these angles are actually just the same. If this is 30, this one here also has to be 30. Let me bring back everything else. Okay, so yeah, that has to be 30. Okay, so with that done, let me put the value there. So we see that this angle here has to be 30 degrees. Now, how does that help us? Well, one last piece of the puzzle needed. How about this one? See, if we can figure out this angle here, then we'll be easily able to find the angle that is between them. Now, how do we find this angle? Well, this angle kind of relates to F1. So, how? Well, this angle here, just like we saw when it came to the 30-degree angle, you have to see that this angle is exactly the same as this angle here. Now, to show you that those are the same, let me just erase a few things here. Then you will be able to see exactly why those two are the same. So let me remove this. Let me remove this and that. So what you quickly see is that F1, these two lines are parallel lines, and since these two are parallel lines and these two are also parallel lines, then if this is, regardless of what the angle here is, it has to be the same as here. So this and that have to be the same angle. This is, whatever this is, it has to be this. Now let's find this angle here. It's easy to find this. Once we find this, it will be easy for us to get, it will be exactly the same as the one here. Now, how do we find this angle here? Well, for this angle, it's quite easy. I hope you're able to actually find it when you go back to the original diagram. Let's see the original diagram somewhere here. So the angle I'm looking for is this angle here. But we are told to say this whole thing all the way from here to there is 75. But this small piece, if this is 75, we expect the whole thing here to also be 75. But since the small fraction of it here is given as 30, then the remaining piece, which is the one we're looking for, has to be 45 degrees. So that when we add 45 plus 30, we get the whole piece, which is 75 and equal to that. So this small piece, the one I'm looking for on the other diagram, has to be 45 degrees. If we go back to our problem, we're now saying that this is 45 degrees. And if this is 45 degrees, this one down here also has to be 45 degrees. Once we have figured out to say that this is 45, well, determining the angle on the middle here is now easy, because we know to say angles of a straight line have to add up to 180. So 30 plus whatever this is plus 45, they have to give us 180. So do the math, this comes out as 105 degrees. So once we have found that this is 105 degrees, we can easily do the math now to find the resultant force, or the force given by F1 plus F2. How do we do that? Well, now I'm going to draw it a little bit more roughly. So what we have is F2 here, and then this side we have F1, and the resultant force, or F1 plus F2, is here. So this is where we have the resultant force Fr. Now, how do we find this? Well, we have determined that the angle between F1 and F2 is 105, and we're trying to find what Fr is. F1 and F2 are given in the question, so implying that here we can use cosine rule to determine what Fr is. So from cosine rule, we have Fr squared is equal to F1 squared plus F2 squared, the two angles that sandwich that angle, the two sides that put the angle between, then minus 2 multiplying the same two sides, F1, F2, then cos the angle between F1 and F2, which is 105. From here, we easily do the math. F1 is, from the question, F1 is 4 kilonewtons. So I'll bring the square root later on. So we have 4 squared plus 6 squared, F1 and F2, then minus 2. And then we have 4 times 6, then multiplying cos 105. So do the math here. From here, you should be able to determine FR as the square root of all this. I can simplify this. So this is 16 plus 36 minus, so this is going to be 2 by 4 by 6, then cos 105. So get the square root of all this. The resultant force FR is going to come out as 8.03 kilonewtons. Since F1 and F2 are in kilonewtons, we expect FR to also be in kilonewtons. So this is what we're finding. Once we have found this, the next part was to find the direction. But before we go there, just a quick thing. You really want to avoid making one mistake with our question. So let me just resketch the problem and show you the mistakes that you want to avoid. One thing that you want to really just avoid here, a mistake that you can easily make here, is to make an assumption that you can find your resultant or the resultant in question by just drawing a line that connects this to that point. So this is one common mistake that you can easily make. I think I've made this mistake before as well. Now, why is this not just going to work? Well, this doesn't work for one simple reason. This is F2 and this is F1 here. What this gives you, if you were to calculate the resultant force in this case, what it would give you is not F1 plus F2. What this gives you is, or this resultant, instead, what it gives you, what this gives you is not F1 plus F2. Instead, if you look at it, if you started from here going towards this direction, what it would give you is F2 minus F1. Because from here, not even F2 minus F1, sorry for that. Notice that you're starting from here, you're moving against F2, so F2 would be minus, so you'd have negative F2, then plus, the other direction now, you're moving along F1, so this would be plus F1. So this is if you're starting from here going in that direction. But if you put your arrowhead in this direction, then notice that the same thing would give you, now you're starting from here, meaning you're moving against F1, so F1 would be the minus 1, so you have minus F1, and then along F2, so this would be plus F2. So regardless of how you look at it, it doesn't give you F1 plus F2. Instead, it gives you either minus F2 plus F1 or minus F1 plus F2. So this is why this approach doesn't work. So instead, we use the other method. For the next part, we now want to determine the direction of the resultant force measured clockwise from the positive u-axis. Well, one thing that you have to understand is the resultant that we expect to get here is not necessarily going to be along the u-axis. So you don't expect it to be in this direction. What we first want to determine is what is the angle that we expect to see here. Not necessarily the angle between F1 and F2, no. But in this approach, we're going to determine the angle from F1 to where the resultant is. So we're going to measure an angle starting from where F1 is until when we meet our resultant force. Now, how do we do that? To do that, let's shift F2 so that we can take it where F1 ends. So we're going to shift F2. So we're going to shift the force F2 so that it comes this side where F1 ends. So once we do that, our resultant vector. So we don't really, for now, we're going to leave out the u-axis. We're going to leave it out. We just want to focus on the triangle created by F1, F2, and the resultant. So let me remove our resultant, our u-axis. So the resultant force is going to be a force that starts from F1 going all the way up to this point. So this is the resultant force Fr. Well, we found the resultant force already in the previous calculation. That was 8.03 kilonewtons. And according to the question, F1 and F2 are known. So this is F2 this side. F2 is given as 6 kilonewtons. And F1 is given as 4 kilonewtons. In this case, notice that the angle then between F1 and the resultant vector here can easily be calculated. How do we calculate that angle? Well, we can use cosine rule again. So we can use cosine rule. This is actually not even needed, as you can see. Cosine rule is enough, or can work just looking at the information that we have here. For cosine rule, we're going to take cos, the angle that we have here, theta. This is going to be equal to the two sides that put the angle between. So this is F1 squared plus F. In this case, it's not F2. So the angle is between F1 and the resultant force. So we're going to have F1 squared and our resultant force squared, then minus 2, not minus 2, sorry. This is minus this F2 now. So I hope you guys know the cosine rule. So minus F2 squared, it's minus the side opposite to the angle, then divided by 2 F1 F2. So this is from the cosine rule. From here we can do the substitution. F1, we know what F1 is, so this is 4 squared plus the resultant force, which is 8.03 squared, then minus Fr, which is F2, which is 6 squared, divided by 2. Then we have 4 multiplying 8.03. So from here, we're going to say theta is equal to cos inverse of all this, which is 4 squared plus 8.03 squared minus 6 squared divided by 2, 4 by 8.03. You can simplify this, and the angle here comes out as 46.25 degrees. So this is what comes out as the angle. Well, what does this really give us? Is this the answer we're looking for? Well, no. Well, what this angle gives us is the angle between F1 and the resultant force. It's coming out as 46.25 degrees. So F1 is here. If we were to make another diagram here, what I'm saying is F1 is here. So I'm now going to remove the v-axis, since for this part it's not necessary, including F2 itself. F2 is not necessary. But before I remove them, perhaps let me just let's look at one thing here. Let's determine the angle that is here, and you'll see exactly where we're going with this. So since this was given in the question as 75 degrees, it implied that the whole thing from here all the way up to here was also 75. So if you less 30 from 75, it gives this angle here as 45 degrees. So the angle between F1 and the u-axis is 45 degrees. So that's what we have. Now let's remove the v-axis and F2. Let's leave only the u-axis, since we want to measure our angle from the u-axis. Now, from our calculations, we saw to say our angle between F1 and the resultant is, from this calculation, we found 46.25 degrees. So the angle between F1 and the resultant is 46.25, but the angle between F1 and the u-axis is 45, implying that if we wanted to find the resultant, we would start from F1, would move all the way from F1, reach the u-axis, but still not have that resultant. Instead, the resultant would only be after we surpass the u-axis. So in the end, our resultant force is going to be somewhere this side. So this is where our resultant force FR is. So that's what we have. Such that the angle between the resultant and F1 is 46.25 degrees. But the question is not asking for the angle measured from F1. The question is asking us to measure the direction from U-axis clockwise. So because of that, let's look at our U-axis. Our U-axis is here. So we now want to measure the angle from the U-axis until when we reach our resultant. We see that we now are only interested in this. But since all the way from F1 to FR, it's 46.25, and from F1 to just U, it's 45, then you should see that if I label this as phi, then we can find phi by just subtracting from, we can find phi by subtracting from 46.25, subtract 45. And if we do this, phi comes out as 1.22 degrees. So there we have it. This is the direction of the resultant vector measured clockwise from the U-axis. Alright guys, this brings us to the end of this class. We'll see you guys in the next class.